Okay, we're going to talk about parallel and perpendicular lines. All right, the slope formula. A lot of people have seen it but don't use it very much, but it's important to know. Okay, these are the y's. You subtract the y's backwards and the x's backwards to get the slope. All right, this is based on the idea that this is the first point, x1, y1, and then x2, y2 is the second point, right? Okay, so we're going to okay, m stands for slope. Okay, we're going to subtract the y's backwards. Okay, so -1 and then minus, right? Okay, and then when you go to the y1, it's a minus as well. So this is minus a -4, but I'm just going to change it because minus a negative, you can change it to plus. So you can change it to 4 like that. Okay, so subtract the x's backwards will be 3 minus a -6. 3 minus a -6, okay? So that's really just plus, all right? Just like this one was. I'm just showing you that's what a lot of people do is they change minus a negative to a plus plus. All right, just don't leave any negatives behind. Okay, so on top you get 3, and on bottom you get 9, which is 1/3 for your slope. Okay, this one, on top you subtract the y's backwards, you get -1 minus 13. Okay, and then you get -3 minus 7. -3 minus 7. Okay, so that's -14 on top and -10 on bottom. And if you divide everything by 2, okay, top will be -7. Well, actually, you got two negatives, it's going to be a positive. Okay, so 14 over 10 is 7/5. Okay, for the slope. All right. And then, okay, let's talk about slope for a second. Okay, if you have an uphill slope, you'll have 2 points on it, and you'll always start from the left, whether it's uphill or downhill. Okay, rise over run, that means you go up or down first, right? If you're plotting a point, like this point right here, you'd go over and up. Okay, but whenever you're doing slope, you go up and over, or down and over, okay? So if it's uphill, you go up, and let's say that's 3 and that's 2, okay? Then your slope would be 3 over 2, okay? Rise over run, start from the left always, okay? If you have a downhill slope, okay? Still got your 2 points, you still start from the left, okay? You go down and over, okay? So let's say that's -3 and that's 2. Okay, your slope would be m is equal to -3 over 2. All right, so you start from the left, up and over, or down and over. Okay, and the reason that we always start from the left is we'll never have a negative on the bottom, and that's less confusing. All right, so here this is a downhill slope, so I start from the left and I go down, and then over. Okay, so that's down 1, 2, 3, 4, 5, so that's a -5 because it's down. And then this one is 1, 2, 3, 4. Okay, so your slope is -5 over 4. Okay, this one's an uphill slope. It looks like it's a up 1 over 2, but I'll just be safe and do it this way. Okay, so that's up 3, and that's over 1, 2, 3, 4, 5, 6. Okay, so 3 over 6, if you reduce that, that's going to be equal to 1/2 for the slope. Like I said, up 1 and over 2 would have worked as well. All right, on tables, pretty simple. I mean, these are just points, right? Isn't that like a comma? I mean, or yeah, like a parenthesis here, parenthesis and a comma in the middle. Okay, parenthesis, parenthesis, comma in the middle. These are points. Okay, they're just in a different form. Okay, so we'll call this the first point. So I'll put x1 and y1 on this one, and then I'll put an x2 and a y2 on this one. Okay, still use the same formula, y2 minus y1 over x2 minus x1. Okay, so I'm going to take my y2 minus y1. So I'm going to take my, whoops, I almost did the other one first. Okay, so that's 14 minus 20, right? 14 minus 20, and then on bottom you do x2 minus x1, which is 7 minus 4. All right, and you get -6 over 3, which is -2 for a slope. Sometimes it's nice to throw the 1 on the bottom because you might have to flip it over and change the sign if it's perpendicular. Okay, this one's weird because if it's like that, the x is on top, but if you turn it this way, then the x is on the right side, which is not the way we usually do it, so it always is confusing for people, so just be careful. All right, so this is my first point, so I'm going to call this x1 and y1 here, and this is my second point, x2 and y2. Okay, making sure you can see. All right, so this would be 8 minus 3. No, I did it wrong. Okay, this is y2 minus y1. Okay, you got to be careful. See, teachers can make mistakes too. Okay, so 8 minus 2 over 3 minus 0, right? And you get 6 over 3, which is a slope of 2. Okay? All right, this is the slope-intercept form, okay, which is y equals mx plus b, where, of course, m is the slope and b is the y-intercept. Okay? And then on this one, if you want to get the m and the b, then that would be simple. That's 3 and 12. Don't put 3x, put 3. It's just the number in front of the x. Okay, here, m and b is very simple as well. This is negative 1/2. This is 7. Okay, it's a little more where you have to think. Okay, m and b. Okay, so m, of course, is negative 4. What's b? Okay, there's nothing there. Now, there is something understood to be there. It's kind of like it's plus 0, right? So the slope is 0. Okay, what kind of line is this? Okay, it has a slope, right? And it's down 1, 2, 3, 4, and over 1. Okay, and it looks like this. Because it's a 0 slope, it goes through the middle. Okay, so it has a line that looks like that. Okay, here there's a 1 for the slope. And for b, there's a negative 5/3. Okay? Next page. Okay, we've talked about horizontal and vertical slopes, or vertical lines, and we use this HOY, VUX, HOY-VUX, I guess. H is for horizontal, and then the O is really 0. That's a 0 slope. Okay, it's kind of like having a sun on top of the horizon, this horizontal line. Okay, 0 slope. Oh, way to memorize it. And the y means that my equation is going to be y equals something. All right, so you look at this, and if it has a 0 slope, it would have been written like this. Okay, 0x, and then it goes through negative 2, right? Okay, so basically the 0 times x is 0, okay, so it just knocks that out, okay, and so anytime you have a horizontal line, it's y equals to the y-intercept, okay, so y equals to 2, which is the y-intercept of this line, so the actual equation is y equals negative 2, I'm sorry, this is negative 2, all right, and that's your equation. Okay, over here we've got a vertical line. I'll just put vertical here. And then do you remember that it's undefined is the slope? Okay, and it's always an x equals wherever it crosses. It's actually x equals the x-intercept. Okay, what is the x-intercept? It's where it crossed at 3. So x is equal to 3. Okay, and it's undefined because of this. Okay, if you're trying to find the slope, you go up 2. And then you can't go right or left, so you have a 0 on the bottom, and whenever you do the 0, divide by 0 on the calculator, it goes and just destroys itself. In other words, it gives you an error. Okay, parallel slopes are the same. You remember, if you have two lines, they got to have the same slope, right? If they're both of them going the same direction, then it's up and over the same amount, up and over the same amount, right? Okay, parallel lines are two lines that will never intersect. Okay, you know that. Okay, perpendicular slopes, we talk about slopes that are perpendicular. Okay, you know perpendicular lines look like this, right? And you got a 90 in there. Okay, it could be a graph where it looks straight up and down as well. Okay, so perpendicular slopes, if you have slopes of each of these lines, they're going to be opposite reciprocals. Okay, we'll talk about what that means. I just got to write it first. Okay. All right, opposite means change the sign. Okay, so we're going to change the sign from plus to minus or minus to plus. Reciprocal means to flip the number over. Okay, it'll be a fraction. Even if it's a whole number like 2, you're going to have 2, you're going to flip it over, right? So you flip it and change the sign. So it'll be negative and then 1/2. Okay, so these are 2 slopes of perpendicular lines. Okay, all right, so if you go through here, negative 1/4, flip it over and it's 4, and it stays positive. I can put a 1 here or not. I mean, it's not going to have it in an equation, but understand that this is flipped over, flip, and then the sign changed to positive. Okay, here you flip it, and you change the sign to negative, right? Here, if you understand that, then you'll do a positive 1/5, right? You get rid of the sign or change the sign to a positive and flip it over. Okay, here we already did it. Okay, write an equation parallel to this line. Well, y is going to equal to 2x. It's got to have that because the slopes are the same if they're parallel. And then I'll just put +5 or something. If I use the same line, it's this, or the same y-intercept, it's the same line, so it won't work. That's a good equation. Okay, so write an equation that's perpendicular to this one. Okay, this is -5/1, so when we write it, we'll change it, we'll do the opposite reciprocal where we flip it and change the sign, and it's 1/5. Okay, 1/5 x minus 11. Very good. All right, now down here, 3 different problems concerning slope. Okay, we've already done something like this. We want to see if they're parallel, perpendicular, or neither. Okay, so this is the x1, y1, x2, y2. Okay, so I'm going to make this small. Let me see, 2 minus 0 on top. That's the y subtracted. Okay, -2 minus 2. -2 minus 2 would be 2 over -4, which is really, if you reduce it, it's -1/2. Okay, so we'll see how this compares. Okay, so x, I'll just use these up here. Okay, so I'm going to subtract the y's backwards. That's 4 minus a -2, right? Minus because of the formula, and then negative because that's a -2. I'm going to put plus 2. Okay, and then 4 minus 1. Okay, so that's 6 over 3. Okay, and that is 2. Okay, so that's 2 over 1. So these slopes right here, aren't they opposite reciprocals? It's flipped over and the sign's changed, so they must be perpendicular. Okay, perpendicular lines. Because the slopes are opposite reciprocals. Okay, this one looks parallel, but you can't go by looks. You got to figure it out. Okay, so I'm gonna go from point to point. I'm gonna go up and over. Okay, so that's up 2 and over 4. So if it's up 2 and over 4, then that's 1/2. Okay. All right. What about this one? Okay, that's up 2 and over. Oh well, it's exactly the same. So it's up 2 and over 4. Up 2 and over 4 is equal to 1/2. So if they have the same slope, what kind of lines are they? Parallel, perpendicular, or neither? Well, of course, they're parallel. Okay, because the slopes are the same. All right, last one. Okay, just a different way to format it here. This one says to find the slope of JK. M, find it for JK, so you have to look at it like that and just do the slope here first, and then LM, you're going to do those two, just like we've been doing. Okay, getting lots of practice here. Okay, so this is going to be subtracted to that one, so let's do that. Okay, -4 minus 6, and then the x's, 10 minus a -2, so 10 plus 2, right? Okay, so that's -10 over 12. If I reduce that or divide both of them by 2, then I get -5 over 6. Okay, that's reduced. All right, now we're looking at this one. Okay, so 4, oops, almost went too far. Okay, 4 minus a -2 is going to be 4 plus 2. Okay, now the x is 8 minus 3, so it's 8 minus 3. All right, and that's 6 over 5. Okay, negative reciprocals or opposite reciprocals. Okay, we used to call it negative reciprocals. Anyway, so, all right, these lines are perpendicular because they are opposite reciprocals. You flip the sign of the slope and changed it. You flip the fraction and change the sign. Okay, because the slopes are opposite reciprocals. Ta-da, we're done. Okay, have a nice day.